Hello, everybody, and welcome to the EAZA Animal Welfare webinar for July. I'm absolutely delighted today to be joined by Ilyena Hirskyj-Douglas from University of Glasgow. Ilyena develops interactive computer systems for animals to control their environments and also to access the internet. She is the director of the Animal Computer Interaction Lab at University of Glasgow, and she's also a lecturer in their computer science department. Ilyena and her team have created and deployed a number of different technologies for animals in people's homes and in zoos internationally, and that's what she's going to be talking to us about today. So her research really focuses on how do we design technologies for individual housed animals and also group housed animals, thinking about how animals can interact with those devices, and actually how can we sort of develop those different technologies to support human-animal relationships and also education as well. If you do have questions for Ilyena, please do drop them in the chat, and then we can come to you at the end of the session. So we've got 45 minutes of the webinar and then 15 minutes for questions at the end. Okay, thank you very much, and over to you, Ilyena. Thank you.
Oh, thank you for the lovely introduction and also for attending and inviting me today. So I thought I would start the talk really by, in case anyone has not really had an introduction to technology before, I thought I would start the talk just by going over a little bit of the history of technology. So we've used computers for a very long time. We as humans are watching this probably on a computer. We listen to this talk today. We tap away at different various devices. Sorry, I live near a main road. Different devices in our house and things like this. Animals too have also used technology for a rather long time. One of the earliest use of technologies was really in sort of defense. So here you see an example on the left of this pigeon project here, done by Dr. Skinner and his team, where they housed pigeons inside these missiles that the birds would control by pecking on with their beak on different target. There's also, we've had a lot of research in the 1950s that started developing around conservation research, so tracking devices. Here you see an early VHF tracking device. Oh, don't know, my camera gone. There we go. Here you see an early VHS tracking device used in the 1950s, and they recorded data here on magnetic tape from a collar worn around animals. This work really started towards how do we monitor animals' heart rates, for instance, how do we monitor animals' respiration, for instance, and started to look at how do we bed technology into animals' collars and harnesses so that animals could be tracked in this way. They did this research on many animals here, from crayfish to elephants, have now been tracked using these sorts of devices. And then more or less around the same period, psychologists began to run a lot of behavioral experiments requiring animals to interact in often rudimentary and quite early operant conditioning chambers with very early versions of computers, which have now upped into these more sophisticated versions of electronic devices. We've seen examples in the 1980s of where people started to look at communication devices. Here you have Coco using the Mac 2, which is a touchscreen computer. Here they were interested in learning things about language acquisition and communication between humans and researchers using lexicograms. And then this also transitioned around the same time and also to different species. So here we have an example of this underwater keyboard used in the 1980s by Marine World in Africa. Washington National Aquarium also used similar sort of things in this. And they were initially prototype versions of this, and they were largely modeled off the earlier versions of these non-human primate technologies. Since then, technologies have massively grown in how we use them in zoos, both in the precision enabled to be able to track and recognize things, and also in the sophistication of what they're able to do. We have examples here of dogs wearing augmented reality, AR glasses here, to give them directions when they're in different situations rather than traditionally use hand signals or audio. For trackers, we still use a lot. You see an example of a lion wearing a tracker here with this VHS, this sort of older technology, but nowadays we use also a lot of GPS tracking. And it's taken a huge leap forward in machine learning recently. So you see here an example of machine learning with ZSL, so Zoological Society of London, have partnered with Google's Cloud AutoML platform. And the idea here is to use machine learning on photos that visitors and people take in a local area to automatically recognize species, and also to recognize potential poachers. And then a lot in zoos of work have been done a lot on tablets and screen devices. So building up further from this early version of Coco, in the Mac, we have a lot of screen devices. Here's an example of one from Smithsonian Zoo here, using an orangutan using a tablet device here. And technology has sort of increased as well on the other side of the enclosure as well, towards people. We get things such as AR interfaces. Melbourne Zoo published a paper actually this year in May about using augmented reality glasses to give further information about when you're viewing animals, for example. San Diego Zoo uses something called eye beacons, which lets their visitors know when animals are near the edge of a habitat or when there's something going on in the attraction. They also use the beacons to send push notifications, to use a smartphone about special events happening in order to get more engagement. And then a lot of touchscreens are coming into zoo. Here's an example from Royal Zoological Society of Antwerp here. You can see them using touchscreens to play games with these bananas. And then Google Earth has also done a lot of work on being able to remotely view inside the zoo. So you don't even need to visit the zoo nowadays to see some of the animals on the inside. Here you can see Google Earth showing an example of inside a rhino enclosure. So you see technologies have massively increased, and then they're also changing in sophistication in both of these sites. However, a large problem really exists here of how do we measure effective enrichment for animals just on this side. Even with this huge, deep history of technology for animals and being used all the way back, we saw from the 1950s, I would say this is one of the largest hurdles. It's really how do we know the enrichment in the technology is effective? What technology would animals want? As we can't just ask them a questionnaire and similar stamps we would do for humans, for example. And this is really important because animals' reactions to technology can be mixed. So we have some examples here where we get decrease in scratching behaviors, reduce in frustration. People have found technologies have provided togetherness, increased agency, increased use of space. There's also been these neutral effects, so people have found that had no effect on the technology. And then there's also some negative effects towards technology. Things like animals turning off the audio if they're provided with audio, animals destroying the technology, initially quite negative reactions and increased aggression. So when we make technology for animals, we obviously don't want to induce any of these negative behaviors, but part of the problem of developing technology for animals is we often don't know what's going to happen. And we don't know also necessarily how to measure the success. Is it if they use the technology? Is it if there's a reduction or an increase of a certain behavior? Is it maybe the zookeepers or other people's opinions of the animal's behaviors, or maybe a combination of all three? And so there's quite a lot to unpack here of how do we make technology that is effective in zoo examples. So to give a more concrete example of this, I thought I would spend the rest of this presentation really going over some of the technologies I've made, and then it will transition into sort of the future directions and where I see this going. So my research with animals and technologies in zoo context really began in Helsinki and Korkesaari Zoo with Kirsi, who was the director at the time. I approached them, and previously a lot of my research in my PhD was in making technology for pets, for dogs. And I saw that the technology that I make for pets in the home to give animals choice over their own environment would really maybe potentially benefit animals in the zoo. And so I began, and they wanted me to work with this white-faced Saki monkey, which monkeys, there were 7 in the enclosure. You can see in the top of example of what they look like here. And we began by looking at how do we enrich their enclosure with audio, so change their soundscape. We started to look at early forms of prototyping, which you can see on the bottom left here, this dish shape and this tunnel shape, and we used materials which were safe for them to sort of pee and bite on and do jumping behaviors. And we started to look at how they use these different shapes. And what we found was they initially rejected this dome shape after biting it. They sort of left it alone, but the tunnel shape they started to use a lot. They would sit inside of it and sort of become a place for them to use. And so we developed technology, which you see in the bottom right here. We use Raspberry Pi inside of it, and we developed it in a way that it would recognize when the Saki monkeys are walking inside of the technology and play them different audio. So the audio we chose was rain, sounds, because it's very much like the sort of pink noise, Zen sounds, electronic music, and heavy traffic sounds. And the reason we chose these different sounds was because auditory, they're quite different sounds in this way. We didn't want to go with typical like human genres of sounds. And you can see an example here. We put the tunnel quite high up inside their enclosure. This is typically where they like to be. And they ended up using the device quite a lot. We found all of the individuals used the device. We found they preferred to listen to traffic noise, so they would use the tunnel more when it played traffic noise than any other sound. And they would use the tunnel more when it played sound than when it had a silent condition altogether. The average interactions was between about 3 and 6 seconds long, up to a maximum of about 15 minutes. So it's quite different to how we would listen to audio. I then started to thinking after I did this sort of study in there, because we analyzed this as a group. So we analyzed all the Saki monkeys as a group, as a group altogether. We started to think about how do we make this audio technology for individuals, and does this matter? For instance, does a group have a different preferred audio, or is it on an individual basis, for example? And so then what I did was I started to look at this similar device, but in lemurs. So I moved to Scotland and started working with Blair Drummond Safari Park. And they have a lemur island here, and they have multiple species of lemurs in the same enclosures. They had 3 species, so they have black and white. You see an example on the left here, these typical ring-tailed ones you often see, and then also common brown lemurs. What we did was we edited the device to be slightly taller, because lemurs have these lovely tails, but they make them a lot bigger than white-faced Saki monkeys. And again, we run the same study, but this time we looked at, do they use the technology differently as an individual? Do they use them differently as a species? And do they use them differently as a group? So here's an example of a video of lemurs using the same technology. And what we ended up finding really was that if you take the results, they differ depending on how you validate the results. So for example, when we look at lemurs' preferences, we found that lemurs overall had no preference for a specific type of audio, unlike the Saki monkeys, but they did use the device more when it played audio than when it was in the silent condition. We also found a correlation with age and usage. So the older the lemur was, typically the longer they would use the device for. But then these results change if you go down to a species level. So if you look at the 3 different species, we found that brown lemurs prefer silence actually more than any audio. And the brown, the black and white and the brown actually increased the amount they used the device for as the study went along. So you can see if you take them as a group, it's different from if you take them as a species. And then if you go further down into them, recognizing them as individuals, you then see that individuals had different audio preferences as well. So for example, here, P6, participant 6 is a ring-tailed lemur. The ring-tailed lemur mostly listened to music compared to P2, which is a brown. And brown, this participant mostly listened to Zen sounds. So it's kind of interesting here that we started to look at, when we start to look at how do animals use technology, it does differ across these 3 levels. And how do we develop technology to understand individual experiences? Such an interesting question. Towards also both how the technology behaves to them as an individual and how we can get them as an individual to change the technologies. Works on both on 2 ways. But then we went back to really thinking, okay, so far we've done so much on audio work here. Is audio really the right way to go in when we think about enriching an animal's experience in their enclosure? And so we edited the tunnel device to put in a screen in the side. This is actually a touch screen, but we didn't use it as a touch screen. We just used it as a video player, and then we put a camera beneath it. And we did the same system again. This time we did it for the white-faced Saki monkeys, and we were looking at when they're able to trigger videos. So whenever they enter inside, it would trigger a different video. Does their behaviors change to using the tunnel when it's audio? So we chose different sorts of videos for them to watch, underwater video, mealworm videos, which are what they eat, different animal videos, abstract art videos, and forest videos. We tried to choose different videos that had different spectrums of color in, which is what you see of the circles here, and different types of movement in there as well. The reason we chose animal videos was because I had this quirky idea that the Saki monkeys could be within the zoo in Kokusari, but then also watch the other animals in the zoo to sort of benefit from being in the zoo themselves. But it didn't sort of work out in that way. You can see here, this is a video of a Saki monkey actually watching a mealworm video. So it's got its hands either side of the video screen. We used this device over several weeks, and here we started to look into their behavior as well into this. We found they significantly triggered underwater and worm videos more than any other videos, and more than the control condition of no stimuli at all. We did find, however, they triggered the videos significantly less as the study went on, so it implies a bit of a heavy novelty effect here. As I mentioned, we looked at their behaviors, and we found so many different behaviors that they do when inside the system. But what we did find was a decrease in scratching behaviors. And the zoo see this as a positive thing, that they wanted to decrease some of these scratching behaviors. We noticed that they did a lot of together behaviors inside the device, so they often use the system together, which we also saw as a positive thing. When we compared the use of audio, though, versus the videos, we noticed that they would actually trigger the audio much more than the video system. And so we sort of think, okay, maybe audio was the right direction to go into. But when we started thinking about this more deeply, the choice we're giving of the animal to use the technology is really just to turn on and off the system. When they enter the system, it turns on, and when they leave, it turns off. And I started to think about how do we give animals more choice inside the zoo enclosure, and maybe it needs to be more of a choice than just an on-off choice. But this is so complex, like how do you build a system that an animal is able to understand that they have more choice, and also to do it in a way that they're able to use the system. You know, how they use their hands is so differently than how we would use our hands. And so we went back to the drawing board, and I started to think about, if I was going to make a button for a monkey, for this monkey, this white-faced Saki monkey, what would this even look like? And so in computer science, you can do this method of low fidelity prototyping, where you just test these really sort of low fidelity versions. You see here are some doorknobs and different items like this. And we started to test these with the white-faced Saki monkeys to see how they would use their hands in order for them to use this as a button to control the computer interface. You can see some videos here. This is some of the early prototypes that we did. This is the Saki monkeys just inside their enclosure. We just got some footage of them sort of playing around. They're always very curious about what we're up to. So what we did was we initially just held out these different sorts of buttons for them to press. Initially, they were very curious about behind it, but you can see it doesn't press with their hands. What they did was they just bit the sort of buttons, and they never did the pressing motion. So it seems that pressing motion for white-faced Sakis, as we would think of a button, isn't really so suitable. So then we thought maybe like a flick version of a button. And again, it was just they sort of bit the flick version and never moved it in the flicking sort of motion we would need to trigger something. And again, they check behind it to see if there's anything else they can do. So they are quite curious. They're quite good at prototyping and testing different items. And again, it's the same behavior, bite. They do a lot of these pulling and grabbing behavior. So we made this sort of interface that they could pull. And this worked quite successfully. You can see they do successfully pull, but it does also cause a little bit of frustration behaviors. You can see here, they're trying to pull this away from the device. So I would say this works quite well as an interface, but it does cause a little bit of frustration. And so we didn't go with this. We went with a swinging button in the end. So you see with this works quite well. They're able to swing. You can see we sort of started to color the interactive items in the device of what we're trying to do, the buttons effectively. And we found this tend to work quite well to signal what we were looking at with the monkeys. But this swing button seemed to work quite well. And so what we did was we edited our system to have these buttons on the side. So now, rather than entering, turning on and off, when they enter, they can choose to swing effectively these different buttons, and it would trigger different videos and different audio systems. So you can see examples here of the video. Again, we put this in the same place, quite high up inside their enclosure. And we did a baseline method, which is where we gave it them without any, we didn't do anything initially for the first week, and then we turned the system on. So this video is actually taken from the first week. And you can see them sitting in there sort of playing around, spinning the buttons around. Unfortunately, this is like one of the only videos that they ever use a system like this, despite all this work we've done around prototyping the different interfaces. Once we turned the system on, they never used it. I think part of this is because they didn't really understand that the system was turned on. How do you signal to an animal that the system is ready to be used or different from when you were testing it during the baseline methodology? And so after this, actually, we started to measure their space usage before we entered the device. And then as soon as we put the device in, it's automatically already interactive, because you risk this initial curiosity effect of looking at the device and getting them to understand that the device does something. Otherwise, we did try to remove the device for a couple of weeks and then bring it back in, but it was already, the interest was already lost in what was going on. And so the takeaways from this really were that white-faced Saki monkeys typically don't really use their hands to interact with computer devices in ways we expect. They much prefer this pull to this push mechanism, and swing is, I'd say, the best mechanism for touchable interfaces for them. And so from this, then I also done a lot of work around how to create interfaces for parrots. So parrots are kind of an interesting species. They live in so many different areas of like our context. You know, we keep them as pets. They're in zoo environments. They're also in wild environments. There's so many different species of parrots. They're extremely sociable. They have a lot of complex needs. And when we keep them as pets, they're often kept alone or with a few others, where in the wild, they're often kept in these large flocks together. And so I started to think about how I could support parrots who were kept in homes, or if for some reason not with other parrots or just with a few other parrots, how I could meet the social need through technology. At this point, I had done a lot of work around I'd started to write papers on how do we connect dogs to each other online. I'd looked at work around dog to people interfaces. So I'd started to get into this idea that two animals separated, the same as we as humans would use Zoom and, you know, this call and various different sort of social media to communicate and connect with each other, that maybe we can also bring this towards animals who can't physically be with other animals. And so I started to develop, me and my colleagues started to develop Parrot video callers in this. And this was a rather long process, because how do you even begin to get parrots to use video callers? We did an initial 2 months pilot study with 4 users. We then moved into asking parrot experts, and then we moved into the study. And the study involved 18 birds altogether, and it involved a process of first we train birds to ring a bell. So you can see here this training of ringing a bell. We then trained parrots to select photos on screens using their tongues here. After we had done this, we then put this all together, so the ringing of the bell and then selecting a photo, to also then meeting the other parrot. So we did this in this phase called meet and greet, where they sort of met each other. Part of this meet and greet phase was also to train the caregivers on how to recognize disinterest. So if the parrot walked away from the system, the video call would end. If the parrot showed any sort of fear reactions or disinterest reactions, the video call would also end. So you can see examples here of this disinterested or walking away and ending the call. So he flies away and the call is end. Oh, you can't hear this one, but he's squawking quite loudly. So the caregiver says to him, okay, we'll end the video call here. So once they had sort of done this association between the different profile photos and the different parrots, and were able to learn to use this ringing the bell and using the tablet system, we then put this all together, enabled them to use this video call system for up to 3 days a week for 3 hours each. So this is what it looks like we're pairing it all together. So she's ringing the bell to call over her caregiver. A caregiver comes over and gets up the profile photos on the screen. And then she selects on the screen who she wants to video call. So our findings from the study, and I'll just play this as an example of some of the calls.
Hi.
So these are two macaws.
Hi.
We found from our study that every parrot we introduced to the system used the system. We found that the parrots reacted differently to different birds. So because they had a choice between multiple birds, some of them, they would actually have favorite birds they preferred to ring. There's an element of sociability there. So actually, the more the parrot was video called, so the more it had calls coming in, actually the more calls it did out. So it's a sociable element. We interviewed the caregivers afterwards, and we got them to keep quite extensive diaries. And what we found was that the system did support their relationships. A lot of caregivers mentioned it gained more trust in their bird, that they felt the bird had more autonomy, that it increased their recognition of the bird's behaviors. So all caregivers reported benefits for themselves, but also for their parrot and also for their and their parrot relationship. Although it is worth to notice that there are potential risks around stress and discomfort here. We did a lot of work around recognizing these behaviors, and also around how to introduce the system without causing any negative behaviors. And it did cause the owners actually a lot of work to set up the system and be available for 3 hours a day, 3 times a week. So I think there is a need to look at how to do this more sustainably actually in the future. So a lot of our lessons here learned were, our initial ideas actually were, we were a bit cautious about the clever hands effect, so the effect that people could have on the system. And so initially when we did the pilot study, we had people set up the tablet, video call, and then walk away and let the parrot sort of get on with it. And what we found was this would then cause the parent a little bit of distress, because then they would wonder, where is my caregiver gone? Like, why have they just walked away? This isn't normal. And they would often then look and call out to the caregivers. And so I think the idea behind creating, even though it's a video call of a parrot, it has to essentially involve also the people around. And it's the same when you work in zoo environments or in home environments, whatever environment you work in, you always need to involve all the people involved. Some parents as well initially showed fear reactions to when the video call would come on. And so we started out with the screen quite far away and the sound turned off, and slowly moved the screen forward and turned up the sound slowly, watching out for any fear reactions to make sure that it was a positive experience for all of the parrots. And so there's this really lesson around this slow introduction. With the monkeys and with the lemurs, you can kind of introduce stuff a little bit fast. They're always sort of on board for things and quite curious, but with parrots, it's a little bit different. From this work, a lot of zoos have then asked me about how to introduce this video call technology for various different species, mostly around non-human primates. And I always recommend sort of initially to try videos of co-Pacifics or, videos of themselves before trying videos of unknowns before, just because you can get these different fear reactions. So from parrots using tablets, what I noticed a lot was really that the touch interface of the screen was not really always ideal. Here's an example of a parrot, for instance, trying to touch a dot on the screen. You can see repeated touches and quite unsuccessfully of this dot. And so what we did was we built an application, you see in the top left here, and that's actually the parrot using our application that presents dots to the parrots, and then we train them to touch the dots. So they touched the dot and got a treat, and then we trained them up into series, so they touched 5 dots on a treats. And this is our setup on the bottom left here, you can see, where we maintained the same distance between them depending on the parrot size. And we ended up doing this with 20 different parrots. And what we were interested in how do we make screen systems better for parrots in this way of using their tongue, so we can avoid this problem of them missing the interfaces. So one of the things we learned from getting parrots to use touchscreens in this way was that parrots often do this multi-touch behavior. It's a bit fast, this video, but you can see it here of them vibrating the tongue on the screen, of doing this multi-touch. And this is because they are so unsuccessful. Often 50% or below of their touches are recognized on the screen. I think this is partly due to parrots' tongues aren't wet, so capacitive touch screens are not so good at actually picking up their tongue. And so they do this crazy multi-touching behaviors. It can be up to 41 times in each tapping behavior. And so what we did was we edited our application, and we edited our application to allow for this multi-touch behavior. So when they did multi-touch, we would just take the first initial touch. We also tested different button sizes, so the different circle sizes and in different placements. And we found that you need a certain size. So this is 100 dp by 26 millimeters size. And when you get up to this size, you can see this button here of this dot is much bigger. They get much more accurate on touching the screen. So you can see here an example of the accuracy is much improved when you get this bigger size. So for parrots, regardless of the size, you really need this sort of size button. You can't go expecting them to press smaller buttons than this size. We also tested for proximity, which is how far apart the buttons are to each other. And what we ended up finding was that actually for parrots, this doesn't matter how far apart the buttons are for each other. And I think this is really because if we look at how parrots use touchscreens,
Touch, 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 touch.
they really touch the screen and then lean back to look away. And we call it this retreat behavior of touching and then leaning back to look away. And so with humans, because our face is so far away from our hands and how a lot of primates use touchscreen devices, they can use the devices quite well because they can see where they're touching. But because the parrots need to lean back, it actually doesn't matter how far apart away things are. With humans, if you put things closer together, they kind of touch things quicker. Further away, it takes us longer. But this isn't the case for parrots. So if you're building an interface for them, you really need these bigger buttons to allow for this multi-touch. And so this project really started to look at how we can edit interfaces to be more suitable for animals. So moving on to like more interfaces for animals, I feel I'm hitting everyone with like a lot of examples here. After I started working with a lot of these monkeys and a lot of the lemurs, Blair Drummond Safari Park started asking me about building stuff for chimpanzees. Chimpanzees are, like parrots, very socially complex, have a lot of needs. Unlike lemurs and white-faced Saki monkeys, you can't do as prototyping with them in the same way, a much difficult situation. You can't really put anything inside their enclosure that isn't in steel. It's a much different scenario here. So what we started with was we edited the system, the audio system we had previously, and we edited it to work through the enclosure bars. So you can see it's set up here with these big speakers and the system is set up. And when they step in front of the device on the other side of the enclosure, it play them different audio. We use different sort of sounds here. Again, we tried to pick sounds which the keepers recommended and also sounds which auditory look different. So we have like ambient sound, traffic sounds, jungle sounds here. We only tested a couple of sounds in this one because it was really us testing if the system would work. And what we found is actually, if you look here, the chimpanzees actually don't start using the system until 25 days into the research study. This is very different from if you were working with lemurs or white-faced Saki monkeys. They would instantly start using the system, and you saw when the system wasn't active within 1 day, they were instantly done with the system. So it was an entirely different learning process of you need to really use these systems for a really long amount of time before they're engaged with. The keeper here also fed back that they were worried that the chimpanzee didn't understand. They had to stand in front of the system to engage with the system. There was nothing that really said this. They just had to serendipitously stand in front of the system. And so we started to build another system for chimpanzees. And you see here, this is us prototyping another system. I started to read a lot of work coming out from Kyoto Zoo of using these visual projection interfaces with chimpanzees. And so we started to look at using projection of colored squares, and when they stood in the square, it would change color and they would allow them to trigger interfaces in this way. What I didn't expect from this was as soon as I bought this projector in, the chimpanzees initially had quite a fear reaction to even just the projector being there, not turned on. And so then we left the projector there, just turned off, and then we turned the projector on, and we just, you see it's blue, we just left it on basically the home screen, just running on, leaving it on for a week or so they could just get used to the idea of projector being there. Projectors are not supposed to be left on that long. We went through a couple of projectors in this study. It's always the way technology just breaks. And then what we did was we then hooked it up to a heater, and when the chimpanzees stepped inside, it would be green. When they stepped inside, it would turn red, and it would give them 30 seconds of heat. The idea behind this was then the chimpanzees, because it can get quite cold in Scotland, could then go outside, play around, come back in, and quickly warm back up. So use more of their enclosure space. You can see here some examples of some videos of when we were testing it out. She's actually using it with her mouth open, so she's just facing towards and getting hot air in her mouth. That's what she wanted to do. So the system was set up so it would only do 30-second increments. So for only 30 seconds it would work, and then they had to step out and step back in again to prevent sort of overheating. See another example here of the mouth open. So we used this system actually for the whole winter, and what we actually found was it was mostly the zookeepers who used this to warm up in the winter. The chimpanzees actually didn't use the system very much. I don't know whether this was because it was the interaction mechanism of standing in front of something, in front of a light they didn't like. I think it's quite hard to design something that's on the other side of the enclosure, and there is this difference. As soon as we put like projector light inside of the enclosure, it did change a lot. So there's a lot of work to really be done here around doing this. Then building off all of at this time, I've been doing a lot of devices, these Parrot internet devices and dog internet devices and dog to people internet devices. I started to look at how chimps behave socially and realized they're really complex, their social behaviors. They have quite different social dynamics. They typically live in big groups, do this fission fusion where they come together and go apart. And I started to wonder if we could support chimps in zoos who don't always live in a big group to have social connections with other chimps. But because chimps can show quite aggression to unknown chimps, it's quite documented, it's a bit challenging on how to do this without causing any negative effects. And so what I started with was I started with playing the chimpanzees videos of themselves. So what I recommended actually to the other zoo. So you can see an example here. And this is just sitting, you can see by the edge of the enclosure, just watching a video themselves, all of one of their troop members. We did it so they could, it just randomly played a video of a chimpanzee they knew. This didn't mean though, even though you see the quite calm reaction here, it was always like this. When the system was first installed, we did have a lot of this sort of behaviors of when the system would come along and immediately run away. We had a lot of curiosity behaviors. So you can see here the system has come on and it's playing a video. I'm leaning in to just have a closer look. But in general, this didn't really seem to show much negative effects. So then we changed the system to show known and unknown chimpanzees. So we got videos of another researcher of unknown chimpanzees, and we changed the system so it would randomly trigger a known or unknown video of a chimpanzee. So here's an example of her watching. So it's an unknown one, so you see the initial surprise reaction, but actually it was okay. We've only really just started looking into this. We found that the female has been tending to use the system a lot more than the two males there, well, than the male there at the time. But we also found that they watch known and unknown, so the amount of time they stay in front of it when it plays in equal amounts. So it implies that maybe known and unknown is both useful to them. But sort of watch this space as more of this research comes about. But why I wanted to talk about this was just to really contrast this against some of the other work is each animal presents different challenges on how to create computer interfaces for them. For chimpanzees, it's a real problem of how do we get them, same as in the monkeys, same as in the lemurs, to really understand and control interfaces, especially because we can't do this low fidelity prototyping. We can't put really these interfaces that we can quickly 3D print or out of wood or build in this way. And so it does present different challenges. And really this grand challenge of understand the interface. If I was going to do stuff with chimpanzees, I would advise people to really have the technology, especially if they've never used any technology before, to have the system just where they can view it turned off for a couple of weeks first, as I think this massively helps to introduce the system. And just to be aware that it can be a long time before the technology is engaged with, which is contrasted to those white-faced Saki monkeys and lemurs in my experience. Again, the chimpanzees, similar to the lemurs, they engage with differently by different group members. So this is also worth bearing in mind. How do you look at this technology? Do you look at it as a troop, or do you look at it as individuals? And zookeepers here played a big part in this. We worked with Blair Drum and Safari Pod, and they were brilliant at helping to introduce the system. They would act positively towards the system. So you can see it's really the holistic method of getting everyone involved in it. Once we had introduced the system with the known and unknown, they actually had much less reactions to the system because they had previously seen the known version of the system with known chimpanzees. So I think the more you introduce technology, actually the less reactions you get. And recently the keeper was telling us we no longer need to do this introduction phase. I think they're used to having these sort of screens available now. And again, I think there is this difference between inside and outside the enclosure of developing technology. So how they behaved with the projector versus the screens, I actually think it worked better outside in our case, but I think it's because we don't have the ideal screen to use inside. And so from this, where do I really see the future of technology going? Well, looking over all these projects, you can really see, I believe there's this move in technology towards systems that animals can control themselves, that they have autonomy over using and agency to choose to use or not to use. So you saw examples here of the ability to turn on and off a system, but also of me trying to go further into the ability to choose. So to choose who to video call, to choose what audio to listen to. The ability of choice, I think, is really paramount to the future of how we use technology with animals. I think that interfaces are increasingly going to be designed for animals. So rather than giving them traditionally human interfaces, similar to how we did with the monkey's hands or we did with the parrot's tongue, we really look at how does the animal's physiology and cognitive ability affect how they can use interfaces, and how can we make interfaces that are more usable for them. I think a lot of interfaces can be used to allow and control elements of their own home. The idea of control itself has been shown to increase welfare, and a lot of animals will use this control even without the thing that it gives. There's a good example by Hannah Buchanan with lighting, for example. But we can give animals things over the heating, the lighting, the audio, the visual, or maybe other species relevant aspects. But it's quite challenging to know how to manage these. So for example, with the heating technology, we didn't want it to go into the, turn up too much heat or be blasted with too much heat. So there is an aspect of how to manage this that needs to be looked into. I think the future of technology is also towards how we cater towards individuality. So how do we build technologies for individuals and also as a group, because we increasingly have zoo enclosures that are multi-species. So how does technology work for different species? How does it work for individuals? Both towards how the technology can be personally adapted towards that individual and how that individual can adapt the technology themselves. And lastly, I think that internet devices, and at the moment I've talked a lot about video call devices, which is very visual, but I think it can go further even than this, can possibly bring something to animals who are physically separated. And how do we do this in a meaningful way is sort of where I think the future of this research goes. And so in summary, animals have been using technology for a long time, increasingly in zoo environments. Technology is not always inherently a good thing. It can cause positive and negative effects. There's lots of learning that needs to be taken place on how to develop technologies in zoo spaces, involving all of these different elements of the different people involved, the different species involved, the different context involved. It's really a complex space to work in. And the future directions I really see it going forward is towards this agency, autonomy, interfaces that work for their bodies, technologies they can control their own and within their own home, individual and groups, and these internet-enabled devices. If you're interested in wanting to see any more of sort of videos of my technology or read any of my papers, I publish in both computer science and animal cognition and behavior. My website is like ilyena.com. You can check it out. And then Animal Computer Interaction is my research group's website if you want to see more wider what I do. So thank you so much for listening to my talk, and I'd like to invite any questions.
Thank you so much, Ilyena. That was really fabulous. Super interesting. We've had a couple of questions come in, so we'll start with those, and then we can take it from there. So going back to the start of your presentation, with the Saki monkeys, did you place the device in different positions in the enclosure to make sure that the Sakis were not just using that as a sitting platform? And related to that, how did you kind of make sure that that was not just being used randomly as well?
Yeah, so we tested out when we were doing prototyping of the device in different areas of the enclosure, and they have this typical routine of going in the circle in the top, and we place it to one side of this. So it was in a path that's near their regular path, but not directly in their regular walking paths of there. It would be a good idea in the future, if I was going to run this study again, to maybe place this in a different area of the enclosure. The problem is you have this time thing of they don't continually use it the same. It does go over time. So then do I introduce two devices? It gets into like a little bit of method quandary really here. But I think about this a lot in terms of, do they just use, because I designed the device of wood to be non-slippy, I designed it so it was plastic over the top so they wouldn't feel enclosed. Does the physical side of how I build these devices attract them alone is a good question, but it's almost impossible to untangle from how they use the device in this way.
Yeah, absolutely. It feels like you've got a lot of aspects that you're trying to deal with. Yeah, brilliant. Thank you. Got another question here. So this person's been trying to promote the use of tech with kind of curators and director, but hasn't so far not been so successful. And obviously there's lots behind those decisions. How would you sort of promote the benefits with curators and directors who maybe are not just focused on welfare? They've obviously got lots of different things to take into account.
Yeah, I mean, it is tricky. It is. I've been very lucky to work with zoos who are open to this. A lot of the technology I develop is on display for the public. I know some zoos are not always interested in this aspect as well. I try, the reason I have it a lot of times on display is I also often try and do signage on the other side. So in Caucasari Zoo and Blair Drummond Zoo, we have signs that we tell them what we're looking at. So for instance, with the Saki, with the lemur tunnel, we had a sign there that said, this device enables lemurs with different audio, and it presents a different way of really visitors engaging in animals and understanding an animal and understanding things like individuality, understanding that, oh, maybe they have different audio preferences, and engaging in a different way. So this could potentially be a way of going into it. But it is really complex because it does take, I'm really lucky, it does take so much of the keeper's time because they have to be involved to monitor how it's going. We have like different people helping us install the devices. We go inside and we use their Wi-Fi and all this different stuff. So it is a bit of I understand it is a bit of an ask sometimes.
Great, thank you. That takes us really nicely onto another question that we had was kind of more about the zookeepers. So you were talking in your presentation about the fact that zookeepers are playing quite a big part, and so you were saying that some of the with the parrots, when you were talking about the people, that like actually that was sort of affecting the relationship between the people and the birds. What's your experience of the different way that keepers behave or approach the situations, and have you found that that's impacted the way that the animal is responding to the tech? And then I guess related to that, do you think it's kind of better to have the keepers there, or is it better that the animals are doing this more independently?
Yeah, so it's very hard because often when we introduce technology, the people involved really want the animals to use it. So with the parrots, they really wanted the caregivers really wanted the parrots to use the system. We actually used a version of the system later on where we did rather than live video calls, they were calling videos to see if they noticed the difference between live and videos. and the parents reduced their video calling usage, and it caused the caregivers a lot of concern. They were like, am I bad at training? Have I done something wrong? So this is what I mean by it affects all of them involved. I've had keepers feed animals right where my technology is to be like, oh, this is a really good thing, and put food in front of the technology, so they deliberately trigger it, because they really want the animals to use the technology. And it's quite challenging this to say, okay, you know, it's the animal's choice and let them do it. But I really think that, like with the people in the parrot situation, with the chimpanzee situation, the keepers really showing sort of it's okay about the device and being quite positive and being quite calm about the device really help the animals, especially when you're an animal that shows initial fear reactions. And it wasn't necessarily the case in the Saki monkeys or the lemurs. It helps towards making them more comfortable around using the technology. I think the keeper's response does play a part in this, but I've never been able, it's quite hard to measure this. So it's quite, and because these are like working environment zoos, these aren't labs, it's part of the variability of just what I work in.
Yeah, absolutely. Thank you. I guess like sort of touching on the sort of the difficulties, how do you deal with the fact that, I mean, you were discussing the environmental aspects and giving animals the choice and control over their environments and change things like heating and lighting. How do you make it so that one animal's decision is not influencing all of the other animals in the collection at the same time?
Yeah, so far, the heating was only at one area. It didn't affect everything, so it affected really the animal that chosen to go inside of that area. It's interesting when you think about to control the whole house, and the audio only the tunnel and the dish were designed so you could only hear the audio if you were inside the tunnel or under the dish. So it means that if the animal didn't want to be in there, they could just effectively leave the situation. When we start thinking about the whole enclosure and making like basically a smart home for animals, it gets a bit more complex because you do have certain elements, and maybe it is more about creating these different spaces where different animals could potentially have different choices.
Cool, thank you. We've got just some general comments as well, just saying thanks very much, really enjoyed the presentation, very interesting topic, and looking forward to hearing and learning more about those studies as well. I guess sort of thinking about the future, we've got a question here on have you started to think about exploring AI with animal welfare in zoos yet? Is that on the horizon for you?
It's nothing that I've thought. I think a lot about AI in terms of just its general use in computer science, but it's nothing I've explored in animal usage. I'm quite cautious about the benefits of AI in animal stuff, especially where there's been a lot recently about animal communication and AI being able to somehow detangle animal communication. I think this tells us a lot more stories about what we as people want to hear rather than necessarily what animals want. And so I start to think about really what benefit can this bring animals and how would this benefit them in some ways. Like the most obvious one would be like, would it be beneficial for a parrot to have an AI video caller back for it or something like this? I don't know. It's stuff I think about, but I'm always really cautious about introducing something that I'm not too sure on the benefit for the animal.
Yeah, great, thank you. I think we've just got, might just have one more question here. Do you see like a future where animals can start to use this tech to actually communicate with keepers? So you've got the agency aspect and them making the choices to do things in their environment, but do you also see them being able to be like, actually, I'd like you to do this for me, or I'd like this providing?
Yeah, so with dogs, one of the technologies I've developed is for my dog to be able to video call me and me video call my dog, this idea of two-way communication with people. It does get a lot. My dog video called me a lot. So then you start thinking, okay, is it, you know, a keeper already has so much to do and it's so much on their plate. Do you really want, for instance, like a chimpanzee ringing you every 5 minutes, asking you to bring more potentially like watermelon or something it really wants? So you start thinking about the ethical side of this, like, is it okay to introduce technology and then remove technology? They talked a lot about this when they introduced sign language for certain non-human primates, and then they took the person who knew sign language away, and I think it was chimpanzees, I can't remember now exactly, would continually sign to the zoo visitors. And so I think about this in ethically, that I don't want to introduce technology that possibly can't be used for a long time, or that also disrupts the relationship in this way. But yeah, when I made the video calls, for instance, with chimpanzees, this could be something that's possibly in there as well. But then you also think, are you really wanting to increase the relationship between the zookeeper and the animal in certain situations, or how would this be managed? So it is, I think about it, but it is quite complex to manage that role. It's different when we have a dog at home or something like this, because the dog lives with us. We have a different relationship with that animal than we do necessarily animals in zoos.
Absolutely. Thank you so much. I think we may have reached the end of our questions. I don't know, do you want to just flick back one slide, Ilyena, so that if anybody wants to get your contact details, they can take them from there. And other than that, just leaves me to say thank you so much for your time. It's a really great presentation, and like I said, there's been lots of positive comments in the chats. Hopefully you can see those. If anybody does have any questions for Ilyena, then there's contact details. Any further questions, there's contact details there. Yeah, and we all very much look forward to seeing your work as it continues to come out. I guess if anybody wants to be involved as well, they can, from a zoo side, they can also get in touch with you.
Yeah, always interested. I speak to lots of different zoos, always interested in this side of things. And thank you so much for inviting me to talk. It's been a real honor.
Amazing, thank you so much. And if anybody wants to catch up on previous recordings, they are on the EAZA YouTube page. This one will go up, and we will share that in due course as well. Yeah, and thank you so much. Have a lovely rest of day, everybody.
Well, thank you all.